Hello everyone. Today we will discuss about substitution reactions which are very important in organic chemistry, and we will see like how this goes on. Okay. So basically substitution reaction you all have studied in class 10th also. Uh, a reaction naming displacement reaction, right? So in which like one group replaces another group. Yes, displacement, double displacement. So substitution is a kind of like a displacement reaction. And here what happens? We have a substrate, we have an attacking reagent that is a nucleophile. And what happens? One nucleophile replaces is being replaced by another nucleophile. Now you see, so we will be getting R OH plus X minus. So this one goes out, right? And this comes in. So one group is replaced by another group, or basically it is nucleophile. X minus is a nucleophile. Nucleophile are electron rich species, anything which has excess of electrons or even lone pairs, so are called as nucleophile. So you can see here one nucleophile is replacing another nucleophile. X minus is replaced by another nucleophile, that is OH minus. So OH minus is definitely a stronger nucleophile than X minus. So this type of reaction is called as substitution reaction, in which X minus is called as leaving group. Right. Now let us see like different types of substitution reactions in our organic chemistry. So today we will discuss about SN1 only. So the first one is SN1. It is called as unimolecular substitution reaction. So in unimolecular substitution reaction, generally if we take substrate, we take our substrate, that is alkyl halide. The substrate structure also like define the rate of SN1 reaction. So if you have taken a tertiary substrate, so this is the order of reactivity: tertiary, secondary, primary. I will add some few more to it, but initially like you can remember like the alkyl halide, if it is tertiary, it is more reactive than secondary and then primary. Then one more thing, the solvent. So इसमें the solvent which we take here is polar protic solvent. So polar protic solvent, what does it? Polar means like anything which is polar, has polarity. Protic means which can release a proton, which can release a proton. So a solvent which can release a proton is polar protic solvent. Like you can know water is an example, and CH3OH is there, like this. And talking about stereo of this reaction, stereochemistry. So generally, it has been observed like if we start with a chiral molecule or chiral substrate, hmm, so we will get a racemic mixture as a product. Racemic mixture, yes. So we will discuss it later, and rest is let us see like what happens in the reaction. You all will be waiting see the reaction. So let us take a tertiary alkyl halide. And let us take any group like bromine attached to it. Then we have a nucleophile OH minus. And then we will be getting this as our product, right? A tertiary alcohol. So the substrate here is tertiary. How to check? So the alkyl halide which is attached to the carbon, check the degree of that carbon. So this carbon is tertiary. The carbon, how to like identify the degree? So the number of carbon atoms to which it is attached, the center carbon. Like this is the center carbon, right? So this is attached to three other carbon atoms. I'm just highlighting 1, 2, and 3. So that's why it is a tertiary carbon, or you can say it is a tertiary substrate. Okay. Now, what is the mechanism of this reaction? Mechanism is very, very important so that you can always tell the right product. And also for competitive purpose. So mechanism involves two steps. So it is a two-step mechanism. Number one, you can say like removal of leaving group to form carbocation. So leaving group here is, this is leaving group, yes, this is leaving group, the Br minus. This is a nucleophile and it is also a leaving group, right? Because it leaves here. So what we can do is say over time. So what happens here? So how to show the arrows? Yes, arrow should be shown correctly. So what will happen? The Br departs because Br is more electronegative, right? Br is more electronegative. So what will happen? The Br will depart like this. The arrow is always pointing towards a more electronegative element. So Br is going to leave, making this carbon center electrophilic in nature. So this is step one, and this is a slow step. So what we will get? So you can see all like we will be getting this plus Br minus separately, and this is positive now. Now whenever a positive charge is placed on a carbon atom, so it is called as carbocation. And this is Br minus the leaving group. Now the first step is complete now. We have carbocation and leaving group. Now the second step is attack of nucleophile on more stable carbocation. Now this line is very, very important, on more stable carbocation. Yes, they are not saying just this carbocation which has been formed. So they are saying like on more stable carbocation. So there is, so I'm just highlighting it. What does it mean? So there is a scope of rearrangement, right? Always there is a scope of rearrangement. That's why they have written more stable carbocation. So what this rearrangement is all about, we will discuss in like upcoming videos. I will upload them. So now let us focus on like what happens in the second step. So our carbocation, which was right here, just formed in the step one. So it will join the party for the second step. Okay. Now what happens? The nucleophile, that is obviously OH minus, it will react, because always in organic chemistry the bond are formed from nucleophile to electrophile, like one which is rich to one which is poor. Yes, so the electron transfer is just like this, and after then this transfer we can get a bond NUE. So this carbon is electrophilic and this one is nucleophilic, OH minus. So what will be the end? And this is a very fast reaction. So we will get this as our end product, right? So this is a two-step mechanism. So this all completes SN1. Now there are something which is very important and which I want to highlight as well. So first thing is slow step. Yes. So you have all maybe gone through kinetics. So in kinetics we study the rate of reactions, like how the reaction varies according with the time and the concentration of the reactants. So basically the rate of the reaction, if we look at the rate of this reaction, rate of reaction. So generally it depends upon the slow step. Now the slow step here is the step 1. So we can say the rate of the reaction, that is R, is directly proportional to the concentration of the species which are reactants in the step 1. So in step 1 the reactants are only alkyl halide or the substrate. So we can say the rate is directly proportional to the substrate, or you can mention alkyl halide, not on the nucleophile, right? So you can remove this and you will get R is equals to K times substrate. K is the rate constant. So the rate is only dependent on the concentration of alkyl halide only, not on the nucleophile, right? And also like this, this is called as unimolecular. Why? Because only one molecule you can see is participating. And the order of the reaction you can say it is 1 right now. So this is all about SN1, right? So but this is just a starting, yes. So SN1 is very, very interesting, because whenever we see this thing which I have highlighted here, this scope of rearrangement, yes, this is very interesting, very, very interesting thing. However, for competitive purpose, because like if I say, like suppose if I say we have structure this and the BR is attached to here, and if we have structure this and the BR is attached to here, right? Suppose this. Now you very well know, like or suppose this one. Yeah, we can take like this. Now you very well know, like this BR. Okay, now they are asking like what are the effective rate of SN1 in these two? Like rate of SN1, like which one of the following substrate will give a faster product? So how to check this? So first of all, we have to check the carbon center, yes, to which the bromine is attached. Now this is primary and this is also primary, yes, connected to only one carbon, right? So both are primary, and we know for SN1 the correct order is tertiary, secondary and primary. Yes, tertiary are very fast. Tertiary, secondary, we can say tertiary is very fast. Yes, secondary is okay, moderate, depends upon the conditions, and primary is poor, yes, very poor in giving like SN1 reactions. So now here both are primary, but still we have to compare, yes, because it's a competitive question. So now what we see, like suppose what happens if we remove this BR, and why this order is there, yes. So because you see here double bond and the positive charge comes up, and after removing BR, and here a positive charge comes up, right? So now these things are known as intermediate, and obviously like this is a carbocation intermediate, and the stability of carbocation is tertiary, secondary and primary, yes. So it is pretty much clear that a tertiary carbocation is more stable than secondary, and then secondary is more stable than primary. Hmm? And that is decoded like this. That is like that can be also found by some other electronic effects like inductive effects and hyperconjugation also. Okay, but we will discuss them later. Now, so these two are both are primary, yes, carbocation. But if you look into resonance, you can see like this one is resonance stabilized. This one is resonance stabilized. You can see here what will happen. Double bond goes here and positive comes. So this carbocation is resonance stabilized. So because it is a stable carbocation, yes. So definitely the rate of SN1 will be, for this it will be greater than this, right? Actually in B it will not happen, yes, you can say. So we have to look into another effects as well, yes. So generally why we are drawing mechanism, because we want to check the stability of carbocation. Yes, so obviously like in one go like you will say like both option are wrong. Yes, why? Because primary substrate. But if we go into depth, if we go into the mechanism, like if you go to the intermediate, then you can easily tell, oh yes, so this is a stable intermediate, so it can form the product. Hmm? So always remember like stable intermediate, like more stable, or you can say it's a very good thing in organic, like most stable reaction intermediate will give you the major product. So to know like which is the most stable reaction intermediate, to know this, you have to know your intermediate, or you have to know the electronic effects and all the uh, rules. Yes. So because if you can find the stability of reaction intermediate, then you can easily tell what the products are. You don't have to memorize all the organic reactions. There are many. Yes, I know. So this is it. Yes. And like suppose if one more question, like suppose if they ask you like this, so the BR, suppose this is a BR, suppose, right? A, B, C. They ask you like which one will give the SN1 faster. So take a pause and think and then tell. Okay. So now this one was a tertiary substrate, right? Three carbons are there. One, two, three, right? So this one is a tertiary substrate. Now this one is a secondary substrate. Two carbons are there, secondary. And this one, the other one, C1, is a primary substrate, right? One is a test. So you very well know like the order is tertiary, secondary, and then primary. So out of this, if we say the rate of SN1 reaction will be greater in B than A, very good, and then this C, right? So this is the correct order. And also remember, because in the end, like I will tell you something very interesting, like in every video, like which I'm going to upload like this. Okay, so the fact is, this fact is interesting fact that SN1 is also called as solvolysis, because here nucleophile is the solvent. Here nucleophile is the solvent. Here nucleophile is the solvent. So SN1 is also called as solvolysis, right? So in competition, generally NEET or JEE, yes, or many other competitions, they just want to confuse students by giving solvolysis. So even if you know SN1 and you are very much confident and you don't know about solvolysis, yes, you can lose marks because you don't know what to do. So this is very important, yes. It is also termed as solvolysis. In competition, they ask not SN1, they ask for solvolysis, yes, rate of solvolysis and all those things. Okay, so thank you and have a nice day. And also like please like, share, yes, subscribe and do comment like how you uh, felt after watching this video. Yes. Okay, thank you. Bye.